So here was minus on, right? Here was minus half. So we just skipped this minus, right? So minus on plus 3 becomes plus 2. Minus on plus 3 becomes plus 2. And plus 2 divided by plus 2 is equal 1. So we get two answers. One is x is less than or equal to 1. And another one is x is greater than or equal to 2. Okay. So our the solution set will be so the value of x is greater than or equal to 2. So we type this way from 2 till plus infinity. Okay.
Yeah.
Okay. From 2 till plus
As it is
infinity.
in property 9.
And another answer is
That's why
less than or equal to 1.
infinity.
So this will be minus infinity to 1. So let's see the figure on point B. Where is on point B? Maybe they have draw the graph and somewhere else. On point 4. Yes, here. Guys, can you see the graph? I mean not graph. This is a real line. Real line. Can you see, guys, the real line?
Yeah.
So our solution was the value of x is greater than 2. So we take this 2 and this will be a solid circle. And we take this to the right side, okay? To the right direction. And another solution is x will be less than or equal to 1. So in our graph, we type this on here and we go to the left direction, okay? So this is our graph. So Chirwa, did you understand, bro?
Yeah, I understand.
Okay. So I think we can now move forward to where? I have no idea where. We have already discussed everything, I think. So we can move forward to this number 48, right? So let me show you this.
এই ভাই আমার তোরা 8 নম্বর শুরু করে দিছ।
আজকে কি আর কিছু নিয়ে পড়ানো হয়েছে ভাই? So maybe we can discuss about our lecture or our lesson on our very first class, right? So we can talk about some real numbers, some decimals. So can
rational number, irrational number.
Yes, a rational number, irrational number. So maybe I skipped something yesterday, and that is okay. Let me show you. So we have finite interval, okay? We have finite interval and infinite interval. So what does it mean? For finite interval, we got something like this. The value of x will be greater than 2 or less than 5, okay? So we got some number like this. If we draw this on the real line, that will be if this is 0, if this is 2, if this is 2, and if this is 5, then the answer will be like this, 2 and 5, and we connect this, okay? So this is a finite interval, okay? So what is infinite interval? Infinite interval will be like this. So the value of x.
I can't see your.
Oh, sorry, I cannot see. I already.
Yeah. Okay.
So for infinite infinite, what does it call? For infinite interval, okay, for infinite interval, we can think like this way: x is less than 5. Okay, we don't have these two inequalities, we have only on inequalities. Okay, like x is less than 5. So if we draw it on the real line, this will be, if this is 0 and if this is 5, it will be like this, from 0 till minus infinity. Okay, so this is called infinite interval. Okay, and for this there is something I missed, that is half closed and half open. Okay, half open and half closed. So let me draw something, half open and half closed. So this will be something like this. Maybe something like this. So we got our half open and half closed interval here. Let me find them in Thomas calculus. Either here, half open. So here on inequalities is like this, less than or equal to, and another one is only less than. Guys, can you see? So in this case, this is called half open interval, and this is also a finite. Okay, this is also a finite interval. Okay, so why this is finite? Because we have our value limited from a, including a, till until b. Okay, so the value of x is from a to b, and the value will include a but not include b. Okay, so this is called half open. So this is also half open interval. The value will include b. Okay, and the value will be from a to b, but this a will not be included. Okay, and for infinite interval, okay, let me take a break for 2 minutes. Okay,
Yeah.
so we were talking about infinite intervals, right? So previously we talked about finite intervals. So what will be infinite interval? This will be so here you see an open interval, right? So the sign is only greater than, and if this is like greater than equal to, okay, so it will be a closed interval. Anytime that if we type this way, greater than equal to or less than equal to, then it will be a closed interval. And anytime if this is a greater than or less than, this will be an open interval. Only for infinite only for infinite only for infinite intervals. Okay, this rule only for infinite intervals, and for finite intervals we get two inequality sign, right? On is here and on is here. So if we get on like this and on like this, I mean if we get on is less than greater than or equal to, and another one is less than, then we tell it half open. Okay, and this is also a half open interval. And for infinite interval, if this is this way, then that is open interval, and if this is this way, then it will be closed interval. Okay, I skipped this on the previous study.
Yes. মানে বড় বড় সমান থাকলে ক্লোজ, আর শুধু বড় ছোট থাকলে ওপেন।
হ্যাঁ, it only for infinite interval, only for infinite interval, and for finite interval it will be different. You see this example, right? this one and this one. We have one like this and another one like this. So we have different sign, okay, different inequality sign. So this will be half open, okay, this will be half open. And at the last we got R, or the real number, set of all real numbers. Here both side will be open, okay, both side, both open and close. Like we have this way, I mean the whole real number line, okay. So for the set of all real number, we get both open and close. We get both open and closed interval, like this way, okay. All real numbers. We don't have A or B or something like this, okay. We have all real numbers. So this will be minus infinity to plus infinity. The solution set will be minus infinity to plus infinity. Okay. So now we can talk about maybe real numbers, rational numbers, okay? So let me tell about unreal number. What is a odd number, okay? What does it tell? Maybe odd number, or that is called unreal number or something like that. So not real number. What is a non-real number, okay? What is a non-real number? So if we get something like this, like something divided by 0, like 5 divided by 0. Get 5 by 0. If we get 5 by 0, this will be a non-real number, okay? And this will be unspecified. Unspecified. That means it doesn't have any value. Your calculator will show like error, okay, math error, or that is math error. And there is another non-real number that is called root over minus something, root over minus 2, or root over minus 3 or 5. It can be something, okay. If we get minus inside of root, then it will be also unspecified, okay. So these two things are a non-real number, and anything else, any number in this world will be real number, okay. Guys, do you understand? Any number divided by 0 will be non-real number, and any number containing minus inside of root over, that will be also non-real number, and anything else that in this world will be any number that will be real number, okay. So now let's talk about rational numbers. So rational number will be, so we take these two example, like minus 3 by 4, we get minus 0.75. If we do it inside of calculator, we get minus 0.75. So we get a lot of 0 after 5, okay. So this is called a rational number. And here we get on divided by 3 is equal 0.3333. So we get a lot of 3 here, like unlimited 3, okay. So this is also a rational number. মানে আমরা হচ্ছে বাংলায় পৌনপুনিক বলি এটাকে, যে মাথায় এটা ফোঁটা দেওয়া থাকে। And if I type a natural number like 2 or 3, or if I type a integer like plus minus 2 or plus minus 3, this will also be a rational number, okay. This will also be a rational number. And what is the irrational number? If something is like this, root over 2, so we get random numbers like 1.4, 1.42, it can be anything else, okay, like 4, 3, 2, 1, 5, 9. We get something randomly, okay. So this is a irrational number, okay. This is a irrational number. So guys, do you understand? Chirwak, do you understand, brother?
Yeah, I understand.
Okay, thank you so much. So here is a real line. So we get some numbers here. We have to do this on this is a rational number, okay. Why? Because -2 is a integer, okay, integer, INTE, integer. So -2 as is an integer, so this is also real number. Sorry, this is also rational number. Rational number. This -1, this is also a rational number because this is a integer. Integer is something like this. Integer is like this, plus minus anything, okay, like +-5 or +-100, okay. This is called integer. And natural number is natural number. Natural number is something like we count when we count some people, okay, like 1 people, 2 people, 3 people, okay. We count this way, okay. We don't count this like this is half people, right? So we count this way: 1 people, 2 people, 1 person, 2 person, 3 person, okay. So this 1, 2, 3, 4, this is real natural number. So all natural number and all integer will be rational number, okay. And also includes this too. Also includes this continuous number, and this is called what does it say? So I mean also include this and this, okay. Also includes something like this and something like this, where we get a lot of 0 on the last side, and where we get a specific number like 3, 3, 3, 3, okay, 3, 3, like this. So far we get a lot of 3, infinity number of 3, okay. So this 2 is also rational number. Or you can think this 2 in another way, like if we think it like m and n. So here m and n will be a natural number, okay. Or m and n will be an integer, okay. Like you can see -3/4. So this is m. If we think it like m by n, so m and n will be a integer. Integer means something like this, plus minus any natural number, plus minus n, okay. Plus minus n, like +-7 or +-50, okay. This is a integer. So if anything is like m by n, where m and n both are integer, then that will be also rational number, okay. That will be also rational number. So where is the real line algebraic properties? Guys, see here natural numbers 1, 2, 3, 4, and integers including 0, right? 0 is a integer. So 0 +-1, 2, 3, like this way. So rational numbers are like a form of function where m by n, where m and n will be, m and n are integer, okay. M and n are integer, and n must be not equal to 0, okay. Why? Because if n is 0, then it will be a non-real number, like 5/0. This This is unspecified, or this is math error. Okay. So that's why we n cannot be 0. Some examples are here, and for so, and we also get terminating zeros. You can see here ending in a infinite string of zeros, like we get 0.75000000. Okay, like infinite number of 0. So that is 0.75. So this is terminating, like our number is ended in here. Our number is ended in 0.75. We have nothing else. So this is also a rational number. Okay. And for B, we got 2.090909. Okay. So we are getting a infinite number of 090909. Okay. Or that is called eventually repeating number. This 09 is eventually repeating so many times. So this is also another rational numbers. Okay. So I think you guys got it, and we have nothing else here. So can we finish our can we finish here?
Yeah, I think it.
I think I understand all.